Hello and welcome back to the channel. In this video we're going to quantify and take off a steel frame structure under NRM2 that will sit on top of the heavy concrete foundation that we quantified and produced a bill for in a previous video. This is the structure that we are going to quantify in this video. It's a steel structural tower which will support a water tank that will sit on this composite decking on the top here. So it's comprised of columns, it's comprised of horizontal bracings and diagonal bracings. Down at the bottom here we have bolt assemblies and we have a concrete plinth. Now, for the purposes of this exercise, we are not going to take off the concrete plinth. Okay, let's zoom in a bit more onto this column base. We've got a column here, we've got diagonals here, and this is called a bolt assembly. It comprises of 4 bolts which are cast into the concrete plinth when it is being poured. There is a base plate which has bolt holes and permits the column and base plate to be bolted into the concrete plinth. You will also notice there is a gap between the underside of the base plate and the top of the plinth, and we leave that 25mm for grouting because the bolts themselves are grouted in, and we put grout to the underside of the base plate to the top of the concrete plinth. But I will show you exactly how that works later on in the video. Let's focus a bit more clearly on this one, so let's zoom in. You could see we've got a column here, as we've said. We've got bracings, diagonal bracings here, diagonal bracings there, but the important thing here is this metal plate highlighted in blue, and this is what we call a gusset. It's a piece of steel plate which is welded to the column, and it's so shaped that it allows you to connect by bolts diagonal bracings, horizontal bracings and diagonal bracings. So let's move up the structure. We'll move up to the first level. Zoom in again. We've got a column here and we've got a column here, and this time we've got a quite slightly larger gusset highlighted in blue, connecting this horizontal bracing, this diagonal bracing and this diagonal bracing, and once again this is welded to both columns, and these are then bolted, these bracings are then bolted through the gusset. Okay, let's move up to the top. And we've got the next level, which is exactly the same as that level. So let's move up to the top, and we've got a slightly different arrangement here. We've got the column here, we've got the diagonal bracing here, and we've got another gusset. So let me just see if I can rotate this slightly. Yeah. Slightly different in shape, but it does exactly the same thing. Here it is highlighted in blue, welded to the column, and allows the diagonal bracing here to be bolted to it. There is also a base bearing plate here, what we call a top bearing plate. Let's just move out and position our model, and I think we can see that if we zoom round, we could see that all those connections are the same on all the sides of this tower. Moving up to the top, let's just zoom in a little bit. We have a horizontal beam here. We have cross beams here, which you can just see highlighted in blue. And these form the support for this composite decking, metal concrete composite decking, which will hold the water tank. And that's what we're going to take off. I will point out that no structural design has been applied to this model. I've just used Autodesk Revit, and its sole purpose is to show you how to quantify and build a steel structure using NRM2. But before we do that, I just want to introduce you to 2 other websites which I think will be useful for us during the takeoff process. The first website I want you to look at is the Interactive Blue Book, And in days gone by, the blue book was actually a blue book, and it was always on the desk of nearly every steel designer. Today it's online. Now as QSers we don't need all of it, but it's very useful to check various sections, steelwork sections. In our project we've got some equal angles, so let's just click on here and see what happens. If you click on then dimension and properties, you will get in the left hand column here all the equal angle sizes that you could wish for. Important for us is that this column here, because this gives us the weight, the kilograms per linear metre. Steelwork is always measured in tonnes, so that's a very useful column. Also you get dimensions as well. Now if we just go back and we go on to hollow sections, because we have some of those in our project, again you've got all the sizes down in this left hand column, and you've got some dimensions here as well, which could be quite useful. Just a quick look then at universal columns, dimensions and properties. Yes, all the sizes, lots and lots of data, the kilograms per linear metre, which is very useful to us as we've just said. And over here at the top right you've got all the various sizes that you can relate to these columns here. So it's a very useful blue book, and now it's online. It's easy to use, easy to find, and I think as QSers we need to know it exists, and also to be able to check the dimensions and weights per linear metre. So very good website. The next website I want you to have a quick look at is Steel Express Limited. There are many websites or many companies like Steel Express in the UK and all around the world, and they are steelwork distributors. So it's not a bad idea to check up on some of these websites and see what sort of steel is being sold, and gives you a good idea and a good background to structural steelwork. But in this particular website, as in there are in many others, is a steel weight calculator. So if we click on services here and go down to steel weight calculator, we have this sort of little calculator, and here you can put your materials in. Mild steel here, and I think if you click on this you've got cast iron, aluminium and acetyl. It may not come through on this recording, but materials, you've got 4 materials you could choose from. You can choose the shape, a rectangular bar as it is here, or a steel sheet plate. You can then put in the width, so we could put in 1000 millimeters. We could put a length in of 1000 millimeters and say a depth of 20 millimeters. And then if we click the calculate button here, it will then give us the weight in kilograms, which is very useful for us as QSers, especially when we're measuring gussets and small sections of steel and we want to know the weight. We can put our dimensions in here and get out the weight in kilograms. And in this particular case, we've done it per square metre, because we've got 1000 millimeters, 1000 millimeters, 20 millimeters thick, so the weight is 157 kilograms per square meter for that particular sheet plate. So these are pretty good. There will be other websites with similar calculators, but I strongly recommend you find your favourite site, if that's the right word, and an earmark or tag steel weight calculator, because they will be useful for you in your in the workplace. Okay, those are the 2 websites, so let's move on. We've seen how gussets work in the project introduction at the beginning of this video. We mentioned cleats, but our project doesn't have any, so I thought I would create a short animation to show how cleats work. Let's start with a universal column. If we want to fix universal beams to it, it would be best if we fix cleats to the universal column at the fabrication shop rather than on site to ensure greater accuracy. So let's do this. Our cleats are just equal angle sections welded to the sides of the universal column. We can then locate our universal beams onto the cleats and bolt them all together. It's quite simple really, and a bit like Lego. The first page of NRM2 Section 15 is what we would expect. Drawings that must be accompanied this section, Mandatory information includes types and grades of materials, welding, testing and surface treatments if required. The bottom half of the page states the minimum information that must be shown on the drawings and includes position of the works, types and sizes of structural members and their connections. The last section is what materials and work is to be included, and not surprising, this includes for the weight of all the components, but with no allowance for the weight of welding, nuts and bolts, etc. The permanent works is deemed to include all the necessary operations to make it all happen. We tend to pay a bit of lip service to these pages in rules of measurement, but as a good QS we must check to see that we do indeed have all this information. Omissions can seriously affect estimating and lead to disputes and claims later on if we're not careful. Turning to the next page, we are fortunate that the measurement rules are fairly straightforward. The majority of the units are in tons, with a scattering of linear metre, metre squared and number, and the odd item here and there. One very important aspect of the rules is that we measure structural steel in two parts. The first is framing and fabrication, and then again erecting it all on site. The reason for this is that there is considerable and different costs in taking delivery of the steel, laying it all out, cutting and fixing all the cleats and gussets, and once that is done, we then have different costs actually assembling it all in its permanent position on the site. So NRM2 Section 15 Item 1 contains the bulk of the fabrication, see Level 3, and then somewhat unobtrusively in Item 2 we have all the permanent erection, and the two quantities in tons should be the same. The language of structural steel is different from normal construction speak, so I will attempt to translate as we go through. Notwithstanding, Item 1 Level 3 contains the most common components, and Google is a good place to look up castellated beams. The usual NRM2 description rules apply, starting with the item in the first column and then building up the description from level 1 to level 3. If you're not sure, have a look at some of my previous videos, but I will be explaining further as we move through this video. Back to our steelwork then. As we move down the left-hand item column, we can see the various options. Most are self-explanatory and become obvious when looking at specifications and drawings. The next one down that concerns us is Item 5, Allowances for Fittings. These are all the gussets and cleats used to fix the beams and columns together and are grouped together with their weight. However, holding down bolts, the big heavy-duty bolts that fix columns to concrete bases, have their own item, Item 10, with a unit of number. Metal decking, which applies to us, is Item 8 with a unit of square metre, and the various heights in Level 1 and the fixings in Level 2 and Level 3. Some other items of note will be Item 13, trial erection. This may occur with complicated structures, but it's not measured unless it is specifically required by the designer or client. Item 17, testing, can be important to verify structural integrity, with all the specific tests being carefully described. Before we move on, it's worth mentioning Item 1 again, which can be found on page 170 of the NRM. Note number 6, built-up work. This is where, due to the design, there are no standard columns or beams that would do the job effectively. So the contractor has to build up the structural element from scratch. This is not a problem, but clearly has to be described very accurately with appropriate drawings and specifications. Okay, let's now have a look at the drawings for this video project. Our first drawing, A100, is the north elevation. This gives us a good visual of the main components. Across the top we have the grids 1 to 6, which will become more obvious when we look at the plan view. Down the right side we have our levels commencing at level 0 up to level 6, and these are important for our takeoff measure. Also on the right we have our descriptions of the structural components. On the left we have our main dimensions between the levels. By the way, we won't be taking off the concrete bases in this exercise. At the top we have the metal decking, and we have more drawings to show the connections. Our next drawing, A101, level 2, gives us a plan view, and we can see the position of the columns and the base plates which are cast into the concrete bases, plus their holding down bolts. We are beginning to form a picture of how the structural members connect, together with the dimensions. So let's move on to the next drawing. Our next drawing, A102, shows the detail of the column base plate gusset. I've shaded this in blue to make it easier to see. This view is of the base of the column, where it connects to the base plate, which is fixed into the concrete base, and the gusset that permits a connection of the diagonal brace to the column and the base plate. For this exercise, all gussets are mild steel 10mm thick. Here we have drawing A103, which shows the intermediate gusset details, again shaded in blue. These can be found at level 3 and level 4. It's a bit more complicated than the basic gusset, but let's see what we can find. Firstly, we have a column-to-column connection at these levels, shown here, plus one horizontal brace and two diagonal braces that all need to be connected. So the gusset shape is a little more complicated than the previous, but still relatively simple. Our last drawing, A104, shows the gusset arrangement for level 5. In this situation, we have a top base plate, one column and one diagonal to join together. The gusset is fairly simple and, as with the others, is 10mm thick. And that's all the drawings we need to quantify the structural steel. We just need a few weight calculations to find the weight of the gusset, for which we have our steel weight calculator to assist us. Let's now move to our first takeoff. Okay, let's look at our first image sheet. Don't panic, it's not as bad as it looks, and I will show you where the numbers come from and their descriptions. Our first takeoff will be the corner columns, of which there are 4. At the top of the description column we have some waste calculation. So what are these all about? Well, we know we have units of tons, and we know that structural sections are described by length and weight per linear metre or square metre. So we need to find the lengths of all the columns and make any deductions if necessary. So from level 2 to level 3 we have a height of 2 metres. But wait, isn't there a base plate to take into account? Yes, and its thickness is 25mm. See drawing A100 and A102. So our true length will be 2 less 30mm, giving us 1.97 metres. Next, we have columns from level 3 to level 5, and these are exactly 2 metres long each. So our dims are 4 by 1.97 for level 2 to level 3, and 8 by 2 for columns level 3 to level 5. There are 8 because we have 2 levels of 2 metres and there are 4 corners to the structure. This gives us a total length of 23.88 metres. Next comes the magic of converting this to tons, and it's quite easy. The next stage is to write the correct descriptions and comply with NRM2. With structural steel measurement, part of the quantification is in the description itself. You will see what I mean as we move forward. So let's have a look and see how this works. Section 15, Item 1, Frame Members, Framing and Fabrication. Level 1, Item 2, Lengths 1 to 9 metres. Level 2, Weight, not exceeding 25 kilograms per linear metre. Level 3, Columns. Note 5, Square hollow section 100 by 100 by 4 kilograms per linear metre. Next, we take the squaring column value of 23.88 linear metres and multiply it by 4 kilograms per linear metre, giving us 95.52 kilograms. We underline this, leave it where it is, then total all the weights up for Item 2, Frame Members, Permanent Erection on site. Our next dimension follows a similar methodology. This time we are measuring the 60 by 60 by 5 kilograms per linear metre horizontal bracing between levels 3 and 4. We can calculate the length directly from drawing A101. We have the centre to centre of the columns as 2.7 metres. Each column is 100 by 100 millimetres, so we need to deduct 2 by half by 100 from the length, which gives us a final length of 2.6 metres. There are 4 faces with 2 members each. which gives us a total of 20.80 linear metres. The NRM description also follows a similar methodology. Item 1, frame members, framing and fabrication. Level 1, Item 1, length 1 to 9 metres. Level 2, Item 1, weight less than or equal to 25 kilograms per linear metre. Level 3, Item 4, bracings. Horizontal bracings 60 by 60 by 5 kilograms per metre, equal angles. Then we take the squaring column value of 20.8 metres and multiply by 5 kilograms per metre, which gives us a total weight of 104.00 kilograms. Next we have the diagonal bracings, and this follows the same methodology too. We can see from drawing A100 that we have 2 diagonal bracings per level change, which gives us 6 bracings per face, and we have 4 faces to the structure. To find the length of these diagonals, we need to visit Revit and take the dimensions from the properties or the similar function in the software that you use. I've got my Revit open and I'm looking at the north elevation. The best way to find out the lengths of members is simply to click on them. So if we go down to the bottom here and click on this diagonal here and then go into structural properties, we can see down here the cut length is 3.1702. This one is 3.1715. There is a slight difference there. It's probably not much and it could probably be ignored, but if you're worried, send an RFI, request for further information, to the designer just to check out. But while we're on this page, let's just look at this one here. So we've got a horizontal bracing there, 2.6. Click on it up here, 2.6. We've got the main columns. Click on that one, that is 2 metres. Now down the bottom we had to adjust it for the gap between the top of the plinth and the underside of the base plate, and if you look it says 1.97 and we did use 1.97 in our DIMS. So I think we can take for granted that these are the dimensions and these are fairly safe to use for our takeoff. Now that we have affirmed our dimensions, we can now show them on our dim sheet. So we have a 3.19 metre length, we have 4 sides and 6 diagonal braces per side, giving dimensions of 4 by 6 by 3.19, producing a total length of 76.55 linear metres. Our description very much the same as before. Item 1, framed members, framing and fabrication. Level 1, Item 1, length 1 to 9 metres. Level 2, Item 1, weight less than or equal to 25 kilograms per metre. Level 3, Item 4, diagonal bracings 60 by 60 by 5 kilograms per metre, equal angles. Then, as before, we take the squaring column value of 76.55 metres and multiply by 5 kilograms per metre, which gives us a total weight of 382.80 kilograms. Next on the agenda are the roof beams to support the profile metal decking. If we look at drawing 105, titled Level 5, we can see we have 2 100 by 100 by 5 kilogram per metre square hollow section beams and 4 70 by 70 by 5 kilogram per metre cross beams. We can also see both of these are 3 metres in length, so our dimensions are quite easy. For the 100 by 100 we have 2 by 3, which gives us 6 metre lengths, and for the 70 by 70 we have 4 by 3, which gives us a 12 metre length. The two descriptions are almost identical, so we have Item 1, framed members, framing and fabrication. Level 1, Item 1, length 1 to 9 metres. Level 2, Item 1, weight less than or equal to 25 kilograms per metre. Level 3, Item 2, beams, square hollow section 100 by 100 by 5 kilograms per linear metre. We take the squaring column dimension of 6 metres and multiply by 5 kilograms per linear metre, which gives us a total weight of 30 kilograms. For the 70 by 70 by 5 kilogram per linear metre beam, we just substitute 70 by 70 for 100 by 100. Then take the squaring column dimension of 12 metres and multiply by 5 kilograms per linear metre to give a total weight of 60 kilograms. We now come to the measurement of allowances for fittings, which is NRM2 item 5. The unit is tonnes and applies to, in our case, all the gussets that are used to connect column to column and horizontal and diagonal bracing connections, plus top and bottom base plates. Consider this like buying potatoes at a supermarket. You pick the potatoes, small ones, big ones, odd shapes, put them in a bag and weigh them, and then you pay by weight at the checkout. The first one is the base plate that connects the column base to the concrete plinth. We can see this on drawing A102. We can also see that the base plate is 340mm by 340mm and 25mm thick. We know that there are 4 columns, so our dimensions are 4 by 0.34 by 0.34, giving us an area of 0.46 square metres. Our description is NRM, item 5, allowance for fittings, level 1, item 1, calculated weight, level 2, item 1, to framed members, and I've written in the component base plate 25mm thick. We know the area is 0.46 square metres, so all we need to do is to find the weight in kilograms per square metre for given thicknesses. So we need to visit our steel weight calculator. I've calculated the weights for you. 10mm thick is 78.5 kilograms per square metre. 20mm thick is 157.00 kilograms per metre squared. And 25mm thick is 196.25 kilograms per square metre. As before, we take the squaring column value of 0.46 square metres and multiply by 196.25 kilograms per metre squared, which gives us a total weight of 90.28 kilograms. Next, we will do the top bearing plate, 300mm by 300mm and 20mm thick, drawing number A104. Our dims will be 4, as there are 4 columns, by 0.3 by 0.3, giving us an area of 0.36 square metres. The description is almost identical. We just substitute base plate 25mm thick for top bearing plate 20mm thick. We then take the squaring column value of 0.36 square metres and multiply by 157.00 kilograms per metre squared, which gives us a total weight of 56.52 kilograms. We have now arrived at the last structural members to measure, the gussets that join everything together. We'll start with the base plate gussets, which join the columns and the diagonal bracing to the base plate. Our drawing shows these to be 0.14 by 0.13 metres in size. The good news is that we measure gussets rectangular or square measure. We don't use trigonometry to calculate the exact area. We have 2 gussets per column and there are 4 columns, so our dimensions are 4 by 2 by 0.13 by 0.14, giving us an area of 0.15 metres squared. If we zoom into a level 2 drawing, we can just see how the 2 gussets are positioned in relation to the column. Our description is straightforward and follows the same sequence as we did for the base plate. NRM, item 5, allowance for fittings. Level 1, item 1, calculator weight. Level 2, item 1, to framed members. And then we write base gusset 10mm thick. We take the squaring column value as before of 0.15 and multiply by 78.5 kilograms per square metre. That's the weight of 1 square metre of plate 10mm thick as per our steel weight calculator, which gives us a total weight of 11.78 kilograms. Next, we have the intermediate gussets between levels 3 and 4. We can see from drawing A103 that our squared gusset dimensions are 0.28 by 0.12. We have 2 gussets per column, as before, and 4 columns, therefore 8 gussets. But we have 2 levels with another 8 gussets, so our dims are 2 by 8 by 0.28 by 0.12, giving us a total area of 0.54 square metres. The description's almost identical, but substitute base gusset 10mm for intermediate gusset 10mm thick. Take the squaring value of 0.54 metres squared and multiply by 78.5 kilograms per linear metre as before, giving us a total weight of 42.40 kilograms. Our last gusset are the top ones. From drawing A104 we can see our dimensions of 0.16 by 0.13. As before, we have 2 gussets per column and there are 4 columns, so our dims are 4 by 2 by 0.16 by 0.13, which gives us an area of 0.17 square metres. The description is the same as before, but substitute intermediate gusset 10 mm thick for top gusset 10 mm thick. Take the squaring column value of 0.17 metre squared and multiply by 78.5 kilograms per metre squared, giving us a total weight of 13.36 kilograms. Our next takeoff are for the holding down bolts that secure the columns to the concrete plinths. We can see these on drawing A101. Fortunately, these are easy to measure with a unit of number, with type and diameter stated in the description. In our case, we have 4 20 mm diameter bolts with nuts and washers, and this is called an assembly. And it is cast into the concrete plinth during the concreting process. So our dims are just 4 by 1, as there are 4 columns, and the description from NRM item 10, holding down bolt assemblies, level 1, item 1, 4 number, 20 mm diameter, mild steel bolts, nuts and washers, level 2, item 2, anchor plates and cones. And that's it. By the way, you may be wondering what cones are for. Well, they are a means of securing holding down bolts in a concrete base which allow for some slight movement of the bolts after they have been concreted in, to make it easier to feed the bolts through the holes of a column base. Let me show you with this simple animation. We could just cast the bolt assembly into the concrete, but that would leave no wiggle room for making sure the bolts actually passed through the holes in the column base plate. To overcome this, we cast the bolt assembly into the holes using location cones. The bolts have anchor plates at the lower end to prevent pull-out. We can then jiggle the bolts around so that the column with its base plate and pre-drilled holes fit exactly. Then we tighten the nuts to hold secure. Once the column is in position, the cones are filled with high-strength grout. So how do we measure it? Well, we've decided it is an and-on to the holding down bolt assembly, but it is not an item in section 15 of the NRM2. We have to go to NRM2 Section 11, page 158, item 42, and it has a unit of number. A bit sneaky-beaky tucking it away in another section, but let's have a look at it. The description is fairly normal. NRM2 Section 11, item 42, grouting. Level 1 dimension description, 340 mm by 340 mm. Level 2, item 1, stanchion bases with high-strength cement, grout 25 mm thick. That should be enough. Its reference to section 11 will appear, of course, in the bill of quantities. You may be wondering where we measure or quantify all the nuts and bolts and washers that connect all the bracings to the various gussets. If we turn to NRM2 section 15 page 169 and look at works and materials deemed included, we can see in item 2 that no allowance is made for the mass of welds, bolts, nuts, washers, rivets and protective coatings. So we can safely assume that all those components must be included in the actual rate for a given BQ quantity and description when pricing it. Next we have the metal decking to measure. To do this we need to review drawing number A105 level 5, which shows us that we have dimensions of 3.00 metres by 3.00 metres, and that's all we need to know. So let's turn to NRM2 section 15 page 171 item 8, and we can see we have units of square metre. So its actual detailed composition is not measured as such. Therefore our dims are 3 by 3, giving us a total of 9 square metres. Our description is NRM item 8, profiled metal decking, 75 mm lightweight concrete composite metal decking, dovetail rib. Level 1, item 2, height 5 to 10 metres, and that's all specification data we have. so a relatively simple takeoff. Our next DIMS take us back to NRM2 Item 2, Framed Members Permanent Erection on Site, where we quantify the weight of all the members. Relatively straightforward, but just needs a little explanation as to how the NRM requires this to be done. Firstly, it's made quite clear that the focus on measurement of steel members is very weight focused. The different members all have units of tons. Secondly, we effectively measure steel members twice. First, framing and fabrication, and secondly, permanent erection on site. This recognises that there are unique costs in fabricating all the steel members to the sizes and specifications, and also unique costs in actually connecting all the members together on the site itself. That's why we have two NRM2 items. Now, the price of wholesale steel will fluctuate on the global steel markets, and designers and estimators keep a close eye on these. But say we want to purchase 50 metres of square hollow sections, 100 by 100 by 4 kilograms per linear metre. This would weigh in at 200 kilograms, and then 40 metres of 60 by 60 by 5 kilograms per linear metre of equal angles, which also weighs in at 200 kilograms. You might think the price would be the same, but it won't be, because there would be different manufacturing costs in producing square hollow sections than equal angle sections. This is why NRM2 requires us to differentiate the weights by member type, i.e. hollow section columns, equal angles and beams, and therefore make the bill of quantities more structural member type transparent. So in practice, how does the NRM2 do this? Well, let's take a look at NRM2 page 170. We can see that level 1, level 2 and level 3 all apply to item 2 as well as item 1. Therefore, in our BQ as well as our DIMS, we must separate the various members along with their weights, and this is what I've done on the DIM sheet. Our first DIM is 95.52 for the total weight of the 100 by 100 by 4 kilograms per linear metre columns. Underneath that, I have totaled the weights of the 100 by 100 by 5 kilogram per metre beams, then the 70 by 70 by 5 kilograms per metre beams, then the 60 by 60 by 5 kilograms per metre bracings, both horizontal and diagonal. Total all this up and we get 672.32 kilograms. The weights of the allowance for fittings in a BQ item is a BQ item in its own right, so that's a straightforward abstraction to the bill of quantities. Our next task, therefore, is to commence the abstraction process to the bill of quantities. I've titled the BQ in accordance with NRM2, but also added a title of the project at the top. Next, we have structural metalwork, the main heading for section 15. On this first BQ page, I have made NRM2 section 15 item 1 the subheading for all the like items. This makes it easier to read than the DIM sheet and facilitates pricing of the items by the tenderers. Next, we have the reference column, but more about that in a minute. So, our first description is for the 100 by 100 by 4 kilogram per linear metre columns. From the DIM sheet, we take the 95.52 kilograms across to the BQ and convert to tonnes. We divide by 1,000. This gives us 0.096, which rounds up to 0.10 tonnes. When we worked out our dimensions on the DIM sheet, we also created the descriptions based on the NRM2 items and columns concept, picking from each to match the construction activity we were quantifying, which gives us the NRM2 code, for example 15.1.1.1, which means NRM2 section 15 item 1, level 1 item 1, level 2 item 1 and level 3 item 1. Apart from some minor formatting, these DIM sheet descriptions will, by association, be the same on our BQ. By the way, NRM2 section 3.3 reference 3.3.2.1.e confirms the unit of tonnes shall be given to 2 decimal places, just in case you wanted validation. Our next BQ entry in NRM2 order is for the 100 by 100 by 5 kilograms per metre beams. the NRM2 code is changed from 15.1.1.1 to 15.1.1.2 to reflect beams rather than columns. As before, we take the 30 kilogram weight across to the BQ and round up to 0.03 tons. Next, we take the 70 by 70 by 5 kilogram per meter beams, NRM2 code 15.1.1.2, take the 60 kilogram weight across to the BQ rounded up to 0.06 tons. And finally, for this first BQ page, the 60 by 60 by 5 kilograms per meter equal angle bracings, NRM2 code 15.1.1.4. The total weight of the bracings is 486.8 kilograms, comprised of 104 kilograms for the horizontal bracings and 382.8 kilograms for the diagonal bracings, taking across to the BQ and rounded up to 0.48 tons. Moving to BQ page 2, framed members, permanent erection on site, we can see from the dim sheet the dimensions are exactly the same as frame members, framing and fabrication. In fact, BQ page 2 is almost identical to BQ page 1. The only changes are the subheading from frame members, framing and fabrication to frame members, permanent erection on site, and the NRM2 references 15.2... instead of 15.1... So that was an easy abstraction. Let's now look at BQ page 3 for allowances for fittings, holding down bolts, grouting and metal decking. Our first abstraction on this last BQ page is allowances for fittings, and I've made allowances for fittings the subheading as before. So our first one is base plates, and we find the dims for these at the bottom of column 1 of the dim sheet, and we have a quantity of 90.28 kilograms. So taking this across to the BQ, we round up to 0.09 tons. Our description is the same as the dim sheet, calculated weight to frame members, base plate 25mm thick, and the code NRM2 reference 15.5.1.1. Next on our list is the weight of the top bearing plate, 20mm thick. We can find the dims in column 2 of the dim sheet, and we do the same as before. Take the dimension of 56.52 kilograms across to the BQ, rounded up to 0.06 tons, and the description, the same as on the dim sheet, calculated weight to frame members, bearing plate 20mm thick, all of which complies with NRM2 code 15.5.1.1. Moving down the BQ to the next dimension to abstract are the gussets. For these I've just totaled all the weights rather than measure them separately. So we have a total of 11.78 plus 42.4 plus 13.36, giving us a total of 67.54 kilograms. Take this across to the BQ and round up to 0.07 tons. The description will be the same as the dim sheet, calculated weight to frame members, gussets, all of which comply with NRM2 code 15.5.1.1. Now, we could have made this simpler in one sense by having just one item in the BQ for all the allowance for fittings, by just adding up all the weights, and that would have been okay and within NRM2 rules. But it doesn't cost any more to expand the BQ still within its rules and give more useful information to the tenderers who will be using the BQ to price the contract. Our next abstraction is the profiled metal decking, 75mm lightweight concrete composite deck, dovetail rib. Again, very easy to abstract. We take the 9 square metre dimension and take across to the BQ. No rounding up or down this time. The description is exactly the same as the dim sheet and complies with the NRM2 code of 15.8.2. Next we have the holding down bolt assembly. The unit is number, and from the dim sheet we have 4 numbers, 1 for each column. This is another easy abstraction. We take the number of 4 across to the BQ as it is. Our description is the same as the dim sheet, holding down bolt assemblies, 4 number 20mm mild steel bolts, nuts, washers, anchor plate and cones, all complying with NRM2 code of 15.10.1.1. This has been a bit of a marathon takeoff, but we are now at the last dimension to be abstracted to the bill of quantities. It's the and on for the grouting. in the dim sheet. We have 4 grouts to do, 1 for each column bolt assembly. Again, an easy abstraction. We take the dimension of 4 across to the bill as it is. The description is the same as the dim sheet. Grouting to stanchion bases, 340mm by 340mm by 25mm thick. This time it's all in accordance with NRM2 Section 11 in situ concrete, so I've created another heading. The reference is 11.42.1.1, and that brings us to the end of the takeoff and bill of quantities preparation for a steel water tank tower structure using NRM2. Just a few takeaways before we close. Steelwork is a discipline all to itself and completely different from the bricks and concrete we have been used to. 2. Read the drawings very carefully. 3. Make a takeoff list. 4. Make sure you understand how to use the blue book. 5. Get to know as much as you can about built-up sections, cleats and gussets, and where the significant costs are likely to be. 6. If you've enjoyed this video, please consider subscribing. And number 7, thank you very much for watching.